this is a complete data engineering guide, especially made for beginners who are confused with so many concepts, so many jargons in the field of data engineering, such as what is stateful streaming, delta lake, medallion architecture, lakehouse architecture, when to pick ETL or ELT, distributed processing, and so many more. So in this masterclass, I decided to teach you all of the concepts from the start, including the modern ones as well, which are essential for anyone who is a beginner in the data engineering domain. And to be honest, this masterclass can be beneficial for the experienced ones as well, and they can treat it like a quick revision and they might learn something new that they didn't know. So in short, after completing this video, you will be able to become a better data engineer because your fundamentals will be so strong. Plus, you will be able to understand the why behind picking any tool, technology, framework, architecture, etc. So without wasting any second, let's directly jump into the video and let's start this masterclass.
So what's up my fam, happy Sunday. And this Sunday we are going to cover an amazing masterclass, as you have already seen the introduction. So basically, let me just give you the very quick overview so that you will also see the agenda. So we are going to cover all of the concepts, all of the terms, all of the jargons, anything that you would have heard or you will hear in the data engineering domain, because once these terms, concepts are clear, you will not face any hurdle. You can easily learn anything. And we have covered everything in detail. Let me just give you a quick overview. So this is the entire masterclass that we are going to learn here. Yes, everything. So by the end of this particular masterclass, you will be able to understand every single thing. And I am really excited to just kickstart this particular masterclass. So without wasting any time, let's get started with this. And just a quick tip, take out your notebook because we are just going to take a lot of notes and we are going to master all of the concepts. So let's start. First thing first is you first need to understand the data engineering role and what exactly a data engineer does. And then only you will be able to understand why this role is evolving a lot with the time. So let's try to see. Let's say you are a user and you are a data engineer, or you want to become a data engineer. So this person, let's say this person's name is Bit2. Perfect. You can just imagine any name if you just want to. So let's say this person's name is Bit2 and Bit2 wants to become a data engineer, or let's say Bit2 is a data engineer. Then this Bit2 will be responsible for the entire data lifecycle. Remember this name because we're gonna just focus on this area. So this person is responsible for data lifecycle. Okay, complete data lifecycle. Now whenever you just talk about the data lifecycle, this data lifecycle will not be the same if I just compare the data lifecycle of today with, let's say, data lifecycle 10 years back. That is why this Bit2's role, or basically data engineering profile, is actually evolving very rapidly, because data lifecycle gets changed very easily and very quickly with the, you can say, more and more advancements, and you can even say like more and more technologies, more and more complexities and everything. So yes, now in short, I can say that if this data lifecycle changes, then this Bit2 needs to improve, needs to learn more and more things, and that's it. Yes, one more thing to note here, data engineering profile, this particular thing was not evolving with high rate as compared to, let's say, 10 years back, because a lot of things were like still under progress. But now, because things are now mature enough, so new use cases are like coming in front of every developer, and obviously opportunities are there. That is why this data lifecycle is now growing very rapidly, and growing means it's being changed very rapidly. And yes, in this particular masterclass, we're gonna just talk about this complete data lifecycle, and we need to just you can say assemble all of the parts of this particular lifecycle again, so that you can understand what each component will do and why do we need to perform all of those components. Perfect, makes sense, because once you are able to see the components, once you are able to relate to these components, only then your fundamentals will be very strong. And yes, we then also gonna talk about all of the frameworks that we use within these components. So let's talk about it. So the very first thing is, which is so common and which actually gave birth to data engineering, it's called data generation. Oh really? Yes. So basically everything gets started with data generation. let's take an example of any web application. So let's say, because everyone uses browser or let's say web application. So let's say we have this web application. Okay, let's say web application. You can here imagine anything. You can imagine your favorite shopping application, you can imagine your favorite grocery application, you can even imagine anything. Okay, anything, because you are the users. Let's say let's bring the users. Let's say we have users. I want many users. Perfect. So let's say we have these users. So we know that users will interact with these particular web applications and these particular softwares, applications, everything. So these people are actually generating the data. Oh, that means you are generating the data. Normal people is generating the data. And with the rise of internet and more and more applications, this data is growing now rapidly. Oh, okay. Because you can see, like, there are so many applications, there are so many web applications, there are so many users, and there are so many functions of these applications. Earlier the applications were very simple, but nowadays we have like application for every single piece. So just tell me one thing, whatever these people are doing here will be stored somewhere. Common sense, right? So for every web application, for everything that you are interacting with using your internet, it can be application, it can be literally anything, any website, any static page, anything. If you're using internet, if you are accessing something, then yes, you are generating data. And even without internet as well, you are generating data. How? We will just talk about it as well, don't worry. So this is your web application. So I mean to say that everything is getting stored somewhere. So let's say web application data is stored, let's say in a database, right? Let's say, let's bring this database. So that means this web applications data will be stored here. Simple, right? So let's say our DB. Perfect. So this is one example of data getting generated. Now sometimes, not every time, like not every time you will generate the data. Sometimes machines will also generate the data. What? Yes. Here comes the concept of IoT. Okay. Sometimes, not every time you are responsible for all the things. So let's say we have any IoT. You can imagine any thermostats, any kind of sensors, anything which are sending some information to us. Okay, it can be related to this thing, let's say users, because for example, let's say you are generating, or let's say you are using an Uber application. Okay, or let's say any ride share application. So you book rides, right? So at that time as well, there are so many events that you send to the you can say storage layer. But here we are just talking about, let's say, independent sensors where human are not involved. Okay, only the machines. So these machines will also send the data, right? So where these types of sensors will send the data, it can be stored in a database, but usually it's not a good practice. So we usually use, yeah, let's say any kind of queue message service. Let's say Kafka, because Kafka is very popular nowadays. So let's say Kafka. But if you're just using, let's say a kind of cloud stack, if you are familiar with Azure, then we have, let's say, Event Hub as well, if you are familiar with that. If not, not a big deal, because both are same things, almost same things. Okay, so this time data is getting generated, right, from the sensors as well. Perfect. So this is like second type of the data getting generated. So here the storage layer is your database. Here it is a kind of temporary storage layer because it is getting generated very quickly. Here it will be literally in the milliseconds. Yes, because obviously, let's say you have to build something on top of any sensor. So that sensor will be sending you the data maybe in every second, maybe in every millisecond. Then you need to store all of that information in these particular solutions. That is fine. Now the beauty is, data engineers actually do not work on this area directly. What? Yes. Here your software engineers work more. Why? Whoever will be developing the web application, it's his or her responsibility to connect a database with that application. They cannot call a data engineer, hey, I have developed the application backend and could you please connect the database with it? It doesn't make any sense, right? And here as well, if you are building some applications and you are receiving the data or you're sending the events, yes, you might need to set up the, you can say, this storage solution which can receive the events It is the work which will be done more on the software engineering side. Then Ansh, Lamba, why do we need to care about this thing? So that's a very good question. Because all of this thing, let me just capture all of this thing. This becomes our source. Wow. Okay, so here comes the second concept. It's called data ingestion. Okay, data ingestion. Cool, makes sense. And remember this word because this word is so important and this word is like often overlooked, but let's talk about it. So as I just mentioned that we do not need to worry about this area much because software engineers will take care of this thing. Cool. But as I just said that this is your source, bro. This is your source. You have to work with this thing. Okay. This is your source. Make sense? Cool. So this is my source and this is the boundary line. Now, yes, with the course of time, this line is getting more and more blurred, but I do not see this line to be permanently vanished very soon. I can see this line getting vanished in the next 10 years, yes, but not immediately. So now, yes, we need like two different type of roles at least for 10 years. So do not worry. So this is the line, this is the source, right? And now you will come into, or basically bit2 will come into the picture. So now we will hire bit2, or we will just call bit2 if bit2 is already a data engineer. Let's imagine bit2 is a data engineer. Let's imagine bit2 is already a data engineer. bit2. So let's say bit2, and bit2 is an amazing data engineer and pro data engineer. Perfect, because he has subscribed to this channel. Good. So let's say bit2. Now bit2 is a data engineer. Now what bit2 needs to do? Bit2 will just ingest the data from these sources. Okay. But how? That comes another concept, because data engineering is full of like hierarchical concept. That is why I'm just creating this video so that you can actually see the entire thing with your eyes. So now what will happen? Now we need to ingest the data. If I want to put this thing in simpler words, ingest means I want to simply pull this data to my side. What is this side? Basically, side means when it will be in your control. Okay. What does it mean? So let's say you are data engineer. Let's say, where is bit2? Yeah. Let's say you are a data engineer. Then this bit2 wants to actually dump the data here. Oh. This bit2 wants to bring this data into his or her, let's say his, into his side, because this line needs to be crossed. Okay, because this is not managed by bit2. Make sense? Okay, so the very first step is data ingestion. Make sense? So now what this bit2 will do, this bit2 will query either a database, or this bit2 will fetch the data from the Kafka source. In either of the cases, bit2 needs to perform something called as data ingestion. But here comes the fact that data ingestion is not just like hard and set rule that you simply need to perform it and it's done. There are two branches. Okay, there are two branches. The first branch is batch ingestion. Okay, cool. The very first is batch ingestion. The second one is your streaming ingestion. If you have heard about streaming ingestion, let's say batch ingestion and stream ingestion. Now let's try to understand this thing, because I know this can be a little bit confusing for some, but let's try to put it in a simpler way. So first of all, let's talk about batch ingestion. Batch ingestion means when you want to pull the data in batches. Okay. What is a batch? Just tell me one thing. What is a batch? You tell me what is a batch. You will say a group of something can be called as batch of students, batch of, let's say, some components, batch of your food ingredients, right? Batch is like just group of something. I'm not teaching you English, but yeah, batch is what? What is batch? Because if you understand batch, you understand batch ingestion as well. So what will happen? Let's say our database. Let's try to put together batch ingestion and this entire data ingestion as well. So let's bring this here, batch ingestion. Perfect. So now when we just talk about batch ingestion, we need to say that, let's say we have a kind of source, and source is, let's say, your DB, because this is one of the best example for batch ingestion. Now we know that in our database, we have so much of data. Let's say in this database, we have 10 terabytes of data, which is not a big thing nowadays, right? So let's say 10 terabytes of data. Now you tell me, should I just bring all of the data together? Should I? You will say no, but I will say yes, you can. Oh, really? Yeah. It is called full load, or it is called, you can say, lift and shift. It is possible. It is possible. That is not a big deal because that is a one-time thing. Now I say that this data will be receiving new records. It can be every single minute, every single second. Like I do not know. There will be like so many records being added, right? Perfect. Now just tell me one thing. Should I bring, let's say this data is being added continuously. Perfect. Now this data will be being added. Okay, there's no, you can say end date, end time or limit to it. There's no upper limit. Then what I will do, I will decide one batch size. Okay, batch size or basically batch limit. I will say, bro, see, we loaded all of the 10 terabytes of data. You will say, yes, I am happy with that. Now I have decided a batch size and I want to say that I need data for every 24 hours. Oh, let's say this much of data was generated in the last 24 hours. This much of data. Okay, let's imagine this much of data was generated in the last 24 hours. What is this thing, bro? Okay, it's fine. So let's say this data was generated in the last 24 hours. Makes sense. Now I will only load this data to my destination. Okay, this is my batch limit. Batch limit or batch size is like the last 24 hours. Then this data will not be loaded. Let's say I am just generating more and more data and more customers are being added, more and more events are being added, anything. Then I will not load this data. Why? This is a batch processing. Then rest of the data will again be loaded with another batch. So this is my another batch. Oh, this is called your batch ingestion. I hope it makes sense. So my batch size is what? 24 hours. That's why you see a lot of modern data engineering solutions are running the pipelines on a schedule, are running on a batch. And I can say that 80% of the current solutions are still using batch ingestion because we are still like relying on batch ingestion. Yes. And within the batch ingestion, we have one more concept that we need to understand. It's called incremental loading. And whenever you are a new data engineering enthusiast, this is the concept that looks like a big thing, but it is so easy. Okay, let's make it easy. So let's say incremental loading. What is incremental loading? Let's talk about, because it is like linked here. Just tell me one thing. When I just loaded this data, this much of data, right? This data. Yeah, this data. Let's say this one. So then I am loading only this much of data, right? Makes sense? And this data is here. Let's say this data is successfully loaded here. Where it is loaded, we do not know, but it is loaded on our side. Simple. Okay. Now you tell me one thing. When I will perform another batch load here with the same window, obviously 24 hours, and this is my next load. Should I load all of the data? All of the data like this as well. Why? Because it is already here. I cannot load this again, or I should not load this again. I just want to load this data, which is the new data. I hope it makes sense. Oh, this is your incremental batch. This is what? Incremental batch. Okay, makes sense. Because you cannot just keep on loading the same data again and again. There are two demerits. Why? First of all, compute. Why are you wasting compute to load the same data which is already loaded? Second, it will just create duplicates. Simple. Then you will just waste your time to remove the duplicates. So it is non-negotiable. You have to perform incremental loading. And in the world of big data, in the world of data, which is like being generated very, very quick, you cannot keep on loading the full data again and again. So there's a difference between full load or lift and shift and incremental batches or incremental loading. I hope this entire picture is now crystal clear, because this is the backbone of your fundamentals. Batch ingestion, incremental loading, incremental batches, batch size, all of these things. Make sense? Very good. So this is like a very high level overview of our batch ingestion. Now let's talk about the second thing, which is our stream ingestion. So what is the stream ingestion? Let's talk about it. And stream ingestion is like a little bit advanced, like little bit complex, but let's try to put it in a simple way. Okay, let's use this color, stream ingestion. Cool. What you have in your mind after looking at this word stream ingestion? What? And what if I say, what is a stream? First of all, tell me this thing, because you know what, when you are able to understand the meanings of words, all of the things are like almost clear. So let's bring this particular thing. Stream. What do you imagine in your mind when you just look at this word stream? Stream means which is flowing, right? Which is flowing. Let's say like this, like this, like this. Continuous flow. So yes, when we want to perform ingestion continuously, then we go with stream ingestion. You want one example of it? Let me just show you the one that we just discussed. Here, just tell me one thing. Let me just first of all take this example. So this is our sensor. This is our source now. So now just tell me one thing. I am receiving events very quickly. Let's say this is my first event, then my second event, then my third event, and these events, let's say in every 1 second, I am just receiving the event. Or let's make it like more realistic, so that you can understand, because if I just break it down in seconds, you will like it's too quick. Let's say 1 per minute. Okay, simple. Let's say 1 per minute. So you are receiving one event in every 1 minute. That is not a big deal. Because here in the database as well, you can receive like events every minute. That is not the differentiation. Here the thing is, I want bit 2. Where is our bit 2? This is our bit 2. So bit 2 needs to use this data immediately, as soon as this data arrives. Why? Is bit 2 in hurry? I don't know, but bit 2 is actually asked to do this thing by, let's say, their stakeholders, let's say their business stakeholders. So these are the business people who need everything immediately, and I don't know what they do with that data, because still the P&L statement is red. But yeah, let's say they just want to use the data immediately. Let's say they just want to do something, right? So this bit 2 needs to pull the data at the same time, or let's say at the very moment when this data arrives here, or let's say as soon as possible, not immediately, let's say as soon as possible. And this bit 2 needs to store the data, let's say anywhere. For now, we can just imagine, like, let's say there's do we have data lake? Let's say any folder, anything. We will just talk about data storage later on, but let's say for now, this data will be stored here as soon as data arrives, or as soon as possible. Why? Because these legends need to take some decisions. Okay, and yeah, they will just change the future of an organization by taking decisions, right? So let's say these business people want to take the decisions on top of this data, right? Cool. So now the thing is, that is not the only use case. Let's remove these people. So let's say this bit 2 needs to run some workflows. How? Let me just tell you. Let's say there is an application, or let's say there is a use case where we are consuming this data and we are simply sending the alerts. Let's say this sensor is nothing but, let's say, a kind of thermostat, right? Thermostat means it will just send the temperature of the room, or let's say temperature of the building, environment, whatever. We want to make sure that whenever the temperature goes below 0 degree, we need to turn on the heat. If you are living in, let's say, the west side, you would understand this thing. So it should be automatically turned on, right? Because the temperature is going down. Then you cannot wait. Temperature is 0 degree. Okay, no worries. We will just ingest this data after 24 hours and we will turn on the heat after 24 hours. Does that make any sense? No. The temperature is 0 degree. I need to turn on the heat as soon as possible. Simple. I can just wait for few seconds, not more than that. Are you getting my point? So yeah, So when you have these kinds of scenarios, when you have to take the decisions immediately, you have to ingest the data as soon as possible. I hope this example, this analogy will just make you understand this thing, because you can just put any example, but I think this is one of the most highly used implications of the stream ingestion. And there are so many, by the way, we will just talk about it, do not worry, but this is like high level thing. Let's say you have a workflow, you have a pipeline that you have built, and you just want to run that thing. And one more thing, by the way, this I think you can just relate to this example as well. Let's say you are using a kind of streaming platform. It can be, let's say, Prime or something, let's say, and you just clicked on one movie. Okay, you just clicked on one movie. Then that information, let's say any movie, and that movie will be saved here immediately, that click. Then this bit2 will ingest this movie name and will just run its workflow. It can be an ML pipeline as well, because obviously you would need to run movie recommendation, and immediately, maybe in the next minute or the moment this person clicks on home page, the home page will show related movies immediately. That is why, let's say, whenever you just let's say click on anything, you search anything, and whenever you just click on home page again, you see the similar stuff, right? That's how it works in the real time. Here, just tell me one thing, can you or can your application wait for 24 hours, or let's say even for 1 hour? No, you have to just show the recommendations right away so that you can keep the customer in your platform. Simple. That is the simple logic. This is where stream ingestion comes very, very handy, right? I hope it makes sense. And yes, Apache Kafka event hubs are like amazing solutions to store these events, and then in order to process it, we will just talk about it after that. But this is your stream ingestion. I hope this concept is clear. Makes sense? So this is all about your batch and streaming ingestion. Cool. Now, Ansh, Lamba, we were just talking about stream ingestion, batch ingestion. Okay, we bit2 need to just bring the data on this side. How? That is a very good question. How? Because, okay, data needs to be ingested, but how? Let's talk about it. Now, let's talk about data integration services, or you can say data integration tools. Perfect. Let's say data integration tools. So because we need to perform this thing, okay, let me just change the color. Perfect. Data integration tools. So you said like how to perform these things. By the way, this is a very good question. In order to perform data ingestion, there are some data integration tools. Do not get confused. You can also write data ingestion as well. Not a big deal, because both are same things. Data ingestion, let's say data integration tools. So here, what bit2 will do, you just tell me, let's say you are bit2. Okay, bit2, listen. Now let's say you need to ingest the data, maybe from Kafka, or let's say Event Hub, and let's say from a DB. Perfect. From any source. Okay, let's say from a file share as well, any file, anything. Okay, you tell me one thing, how would you do that? You will say, I don't know. No, you know. Just think about it. How will you just do it under the hood? Just use your a little bit of common sense. You will know this thing. The answer is very simple, and you already know this thing. You will create a client, right? Because you will create a client on your side. Simple, cool. And these are the servers under the hood, obviously. So you will create a connection. Okay. You will create the connection. Make sense? Once you create the connection, you will be able to connect to this thing. And once you are able to connect to this thing, then you can just use their APIs, their, let's say, methods that they have built, SQL engine, SQL queries to pull the data. Because every source will have its own way to read the data. Here you use SQL. Here you use, let's say, some methods. Here you use, let's say, some API endpoints, anything, right? So either way, you will create a connection. Simple. And you will create a client out of it. How to create a client? In most of the cases, we use programming languages. Let's say Python, because Python is the fundamental language for data engineers, and we love Python. Who is saying Scala, bro? Who uses Scala, bro? Who uses Scala? Let's say Scala. I'm not a big fan of Scala. Ansh Lamba, because you do not know Scala, that's why. Oh, really? Okay. Cool. Okay, I do not know Scala, but yeah, I love Python. See, so let's say you will use any programming languages, Python or Scala, and that was the standard so far. Not so far, I would say, till early days of data engineering. But then we were just writing so much of code manually again and again, and that was not very much efficient. Yes, there were some brilliant coders, brilliant programmers who were able to create these kinds of connections seamlessly, but not everyone is, right? So here comes the opportunity to automate this thing and create a business out of it. Okay, so here we have like amazing data ingestion services or data ingestion tools. Let's say, for example, we have Azure Data Factory. If we have a logo for it, Azure Data Factory. Or you can say Fivetran. If you have heard about Fivetran is actually a very popular or very good data integration service right now. And there are like so many. These are like two popular ones that I have just picked. So what they have done, they have literally created these connections, nothing else. Obviously, they have provided more and more services, more and more features, more and more compatibility with so many sources. And do you know what? These are not just like your connections or just your client side. These particular things, these services are so good that you get connection. You get connection opportunity, or let's say any like code for all of these particular sources. There are so many sources. You cannot even learn the entire list of sources. Okay, so now the modern flow is you use these services to create a client instead of just creating the client using Python or whatever. I hope it makes sense. And I'm just telling you, bro, the list is very long for the sources. So this actually does the work for you. The best thing here, you do not need to write the code. It is no code. That's where the opportunity of, you can say, no code data ingestion comes into the picture. And that is why you see nowadays that people say data engineers do not need to know programming, blah 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 blah. But it is not the complete truth. Yes, for data ingestion we do not need to know the programming, because you cannot match the standards that they have created to ingest the data. Why? Bro, their entire business, their entire, you can say, organization is built on just one thing: creating connections. So how can one person, two people, three people can actually write better code than them when they have the entire funding to actually do the one stuff? Just think about it. So when these problems come, these solutions are the actual way to go with it. Here I have seen some people still write the code using programming and Scala. It is not a bad thing, I'm not denying that. But when you just want to build the robust production ready solutions for your organization, when the data driven decisions are so important, then obviously go with these particular solutions. Make sense? Good. So this was all about your data ingestion tools and services. Make sense? Okay, so now I hope now you have like little bit understanding of like why ADF is so popular, why Fivetran is so popular, and now there are like so many other things as well. And obviously this video is not sponsored, so why do I need to take brand names? Okay, so now, because see, we just need to learn the things. We are not promoting anything. So now let's talk about a very important concept called and you would have heard about this thing. I am 110% sure. This is called ETL. Yeah, you have heard about it. I know. ETL or ELT. Let's talk about it. One of the most talked topic, ETL versus ELT. The thing is, you tell me one thing. If you are ingesting the data, right? First of all, let me just write the full form of ETL and ELT. So ETL stands for extract, transform, load, and ELT stands for extract, load, transfer, load. Ansh Lamba, there is no ELTL. Yeah, but the complete definition is ELTL, but we just use ELT. Okay, cool. Because I didn't create this abbreviation. If I would have created it, I would just write ELTL. There's no ELT. So again, we will just make some changes here as well. Let's say ELTL, because this is the complete thing. But yeah, if you just read ELT anywhere, then yeah, this is the same stuff. Okay, cool. So now the thing is, what is extract? What is extract? Extract means when you are ingesting the data. Oh, so this E in ETL is extract. Ansh, Lamba, we do not even know about ETL. What is ETL? ETL or ELT, or basically ELTL, is a kind of your data lifecycle. Really? Kind of. Kind of. Okay. So when we just want to talk about data lifecycle, this is not the complete data lifecycle, by the way. There are so many other things as well, but from the development point of view, from the, you can say, building point of view, yes, ELTL is the data lifecycle just till development level, because after development we have so many other things as well, like governance, security, all of these things. But yeah, this is for your development point of view, like building point of view. Okay, cool. Now the thing is, in this particular ELTL, the first step is extract, which is ingestion. So we ingested the data. Now you will tell me, because you are very smart, you ingested the data, you extracted this data, right? What you will do after extraction? Some people will say, bro, I just you tell me. Let's say you are in a farm. Let's say, do we have fruits? No. Do we have farm? No. Do we have land? Yeah, perfect. Let's say you are in a farm, okay, and you are Bittu, and Bittu is a farmer today, okay. He's a farmer on the weekend and data engineer on the weekdays. Perfect. Perfect combination. So let's say this Bittu needs to let's say pull some fruits, okay, from a farm. Let's say some mangoes. Okay, cool. So this Bittu has plucked some mangoes. Cool. And now Bittu has, let's say, 10 mangoes. 10 mangoes. Now Bittu is actually holding these 10 mangoes in both the hands. Wow. Bittu is very strong. Bittu is holding 10 mangoes. Now tell me, like, what Bittu should do? Data is extracted. Mangoes are in the hands. What this Bittu should do? Some people will say, bro, let Bittu keep these mangoes somewhere else for the moment, so that Bittu can bring more mangoes, right? So some people are saying, let Bittu drop these mangoes somewhere. So this becomes your load. Oh, okay. Okay, this becomes your load. Some people will say, Bittu should not simply drop the mangoes, because it's not a good practice. It's not a good habit. Bittu should first wash the mangoes, and then Bittu should load the mangoes, because these mangoes are like edible. We need to first of all wash it, let's say. So then what will happen? This Bittu will first transform these 10 mangoes, basically clean the mangoes. Perfect. And then this Bittu will, let's say 10 mangoes are transformed, then these mangoes will be loaded. Cool. Makes sense. This is another way, and this is the first way. I hope it makes sense. Wow. Now you will tell me which is better. Ansh, Lamba, I think I don't know. Obviously, because there is no straight answer to it. Now let me just tell you this approach, where Bittu is actually washing the mangoes and then loading it into a bucket, into anything. This is called ETL, because this is E, right? This is extract. Cool. By the way, this analogy was not planned, and this analogy is so good that I'm loving it right now. So this is extract, right? Then here you have transformed these mangoes, you have washed them, right? Then you loaded it. This becomes your ETL. And here, what will happen? Let's complete this as well, right? So Bittu loaded the mangoes. Perfect. Now what will happen? Now Bittu will load more mangoes. Makes sense, because this Bittu will just first of all focus on loading more and more mangoes. So let's say 10 more mangoes, 10 more mangoes, 10 more mangoes. Perfect. Now Bittu is saying, wow, we have 30 mangoes. Good. Now let me just wash them all. Okay. Now these mangoes will be washed together. Cool. Perfect. And now after After washing these mangoes, then these will be loaded in a bucket. Wow, I hope it makes sense. To be honest, this analogy is so good, so good. So this is your entire cycle. So this is your ELTL and this is your ETL. Cool. So now you will tell me, this view is so good. See, ETL, ELTL, and this way. Perfect. So now you will tell me which approach is better. No approach is better. Okay. Because both are good. It depends upon the use case. So now what was the thing when we were not introduced with the big data, when we were not having a lot of data getting generated, we were only focusing on the ETL. Okay. We were only focusing on the ETL. Okay, cool. Because we were loading 10 mangoes, because mangoes were like just 10, we were just transforming immediately and we were just loading. Then bit 2 was going again, 10 mangoes, washing and just loading. Perfect. But then with the course of time, we actually got so many mangoes. We get so much of data, 100 mangoes immediately. Then we were not wasting our time to transform the mangoes before, obviously. So we were simply dumping all of the mangoes first. Then once the mangoes are dumped, once the mangoes are stored in some location, then we were just transforming them together. And then we were just finally loading them so that anyone can eat, anyone can just do anything out of those mangoes. Okay, so this approach is modern approach. Or I can say not modern, because see, ETL is still being used. Okay, so let's say big data approach. Okay, and this is normal approach, ETL. So I hope now you have a crystal clear answer that whenever you do not have much data, you go with ETL approach. When you have big data, and we will just talk about big data next, when you have so much of data, you simply load first and then transform and then load. I hope this makes sense. This analogy makes sense. Okay, perfect. Now let's talk about big data, because now is the time to talk about big data. We talked about big data. So Ansh, Lamba, just tell us about big data in depth. Okay, one of my favorite topics, big data. Because this topic is like full of suspense, full of new things, and we are still like discovering so many things, and no one is actually a pro in big data. I do not consider myself to be a pro. I still consider myself at a very beginner stage, because big data is actually very complex, and the people, the smart brains who have made this big data or working with big data possible, they actually know everything. We just know how to just like we just know the tip of the iceberg, to be honest. So yeah. So yes, there are so many things. So do not feel bad if you do not know about big data, because no one actually knows everything about big data. Big data is like so in depth. So this is big data. So what actually happened in our past few years that we are now dealing with big data? If you remember, I just talked about data generation. Let's go here. Perfect. Now this data was getting generated really quick. And in the world of AI, data is being generated more with AI than you. Obviously, because whatever response it is giving to you is getting stored somewhere or needs to be stored somewhere or anything, right? So now the thing is, data size was growing very rapidly. Okay, let's say this is our data. Do we have a very good thing for data? Let's say this is our data server. Okay, cool, perfect. Let's say this is our data. Now the thing is, the size of this data is growing rapidly. Okay, and we were not able to handle it. What does it mean? We are not able to handle it in what way? Let's talk about it. So let's say this is our data, and the data that was being generated was not handled by us because of 3 V's. 3 V's of big data, which is like very popular. And these 3 V's are, first of all, velocity. First of all, volume, because this is like very easy to understand. Volume. First of all, volume. Data size was increasing rapidly. Volume of data was increasing rapidly. Okay. Second, velocity. You can just imagine velocity as speed. Now some physics toppers will say, hey, velocity and speed are different. Okay, bro, I know velocity and speed are different, but just from the understanding point of view, let's say velocity is speed, like how frequently data is being generated for your use case. So data was being generated very quick, so velocity was increased. Third is variety, which is the most important stuff. Variety. Perfect. Variety. Earlier, when we just introduced, not we, basically the people behind databases, they introduced a concept called database in around 1970s when they wanted to store some data, right? So now this database was only responsible for storing structured data. Makes sense. But with the time, we got images, videos, semi-structured data, like literally everything, and we wanted to process that as well. For example, let's say currently all of those AI models are able to generate the images. How? Because those are trained on images, right? So we fed so much of images, and we fed so much of maybe videos or pixels, anything, right? So we use this data, only then we are able to work with AI. So this is obviously a subset of big data, bro. So variety was increasing. So in order to mitigate all of these three problems, we were not able to store the data in your traditional databases, because this alone DB cannot handle everything. Cannot. Okay. So this was not working. Okay. Then we introduced something called as data lake. Cool concept, very fancy name, but do not worry, let me just put it very easily. So data lake is what? Data lake was a solution which was created around, I think, early 2000s. Okay, I do not know the exact year, but it was created in the early 2000s, and data lake solved all of these problems. Well, volume, velocity, variety. Let's talk about first of all the variety, because this is the most fascinating thing, and then we're gonna just talk about the volume and velocity. So as we know that whenever we want to store the data in the database, we just store the structured data. But you know what? Let's say let's bring our bit 2. So let's say bit 2 wants to store the data in the data lake. Okay, this bit2 can actually upload any data. Let's say this bit2 has a file, any text file, anything. Okay, now what will happen, this bit2 can actually upload the data in the data lake. What's so special in the data lake? Let's talk a little bit in detail. Okay, just few behind the scenes of data lake. So now there will be a kind of user interface which is nothing but just your APIs. Okay, let's say blob API. Now what is this blob API? So data lake is actually built on top of your blob storage, and here you will be having on blob API. And do not worry, you do not need to actually understand the behind the scenes, but just for your, or let's say just for curious people. So let's say there will be a kind of blob API, or basically blob user interface. Cool. And let's bring one interface, let's say this one. Cool. And here you will upload your file. Cool. Let's say like this. Okay, you can even use the interface, or you can even use the APIs, because this is a kind of blob API. So here we have, or basically anyone who would have just created this data lake. For example, let's say we want to work with any cloud storage. In our case, it can be S3. Okay, let's bring S3 under the hood. Perfect. So let's say this is our S3. Okay, cool. Data lake. So now what will happen, this S3, this AWS team would have created one distributed software which will take care of this particular file. Okay, cool. So let's say software. Okay, then this file will be converted into small chunks, as we all know, because this entire file will not be like saved as it is. So this will be converted into these chunks. Sorted. Okay, so far so good. And each chunk will get its metadata from this software. Cool. Metadata regarding the creation date, the address, everything. Then these chunks will be distributed to so many machines. Okay, cool. Now let's say so many machines, we call them as, let's say, nodes. Perfect. So let's say this is distributed among so many machines. So now what will happen, you will only see this one large object. That is why it is called as binary large object. You will never see these chunks. You will never see how these are like saved inside your normal computers, right? Or basically nodes. And yes, these chunks will be converted, or let's say these chunks will be saved as your blocks in these machines. Okay, I hope it is simple. This is just like behind the scenes, and that's it. We are not going in depth. So simple. Cool. So these are your blocks. Okay, so this is the interface. Now you can upload any data, because any data can be just saved like this. Wow. And how will you just access this data? Using this interface. Using this interface or using the API, you will get the response back. Okay, that makes sense. I hope this is simple. So with the data lake, our variety problem is solved. Our velocity problem is solved, because we can just save or basically ingest data as much as we can, and obviously as frequently as we can. Okay. Third thing, volume. Ansh, Lamba. Let's say variety is not a problem. Let's say velocity is not a problem. Why volume is a problem? Why? We can save terabytes of data. Let's say you want to say 10 terabytes of data. Yeah, just save it. But the thing is, when databases were created, do you even know how expensive they were in order to store the data? If you would need to store, let's say, 1 terabyte of data, forget about 10 terabyte, you would need to spend billions of dollars. Billions of dollars. Are you serious, Ansh Lamba? I am serious. You can even check. Okay, you can even check on Google. And I'm just talking about the early days of databases, like in 1980s. You can just check the price. Okay. So now we can save the data in database with high volume. That is not a problem, but cost is the problem. So is data lake free? Obviously no, but data lakes are very, very cheap. They are very inexpensive. Why? Because here you do not need to maintain this dedicated virtual machines, because these chunks are distributed over so many machines. Does that make any sense? Yes. And in the early days of data lake, we didn't directly get the cloud data lake. We first got the, you can say, on-prem data lake, where people just were using like on-prem clusters, like you can say physical clusters, and they were just creating their own data lake. Then immediately within a few years, we got cloud solutions like AWS S3, ADLS Gen 2. We got like these many solutions. Make sense? So data lake solved this particular problem with our data, or basically big data. I hope it makes sense. So this is the rough idea why we are in the big data era, and why these databases are good, but why data lakes are evolving, and why data lakes are more in demand. And these are the 3 original V's. Yes, nowadays we even have, let's say, 6 V's, 9 V's. So there are so many V's, but these were the original 3 V's. Now we have, let's say, veracity. Now we have so many other things. You can just imagine any problem with data, just find the word with V and simply add it. Simple. Because now we have like so many V's. Okay, cool. So we understood the concept of big data, and now you should know like why it is such a big thing. And now I want to ask you one thing. If I will ask you where you will load this data here in case of ELTL, what should be your answer? The answer is very simple, bro. And you know this thing. Data lake. Oh, yes, data lake. In most of the cases, it's not like hard and set rule, but because you are just building your ELTL solution, you will load your data in your data lake. Cool, very good. And if you are building ETL solutions where you can just load the data, yes, you can load the data in the data lake, but ETL solutions are not actually for big data. Then you can just pick something called as database, which is actually a better choice, or I will say popular choice with ETLs. That is why the outdated, or you can say those junior level solutions where you just build ETL pipelines, you just perform a simple solution to just load the data in the Postgres database or MySQL database. That is also good, but now you need to understand that is just ETL. that was popular but not much anymore. We are now in the ELTL era, in the big data era. I hope it makes sense. But yes, in the early days, you need to first build ETL pipelines, because only then you will be able to build these pipelines. Okay, so nothing is wrong. There is just, you can say, the ladder that you need to climb, and that's it. Cool. So this is all about big data. Cool. So now I want to talk about something called as, okay, we loaded the data. Okay, so now we will be just referring to our data lifecycle as this one. Okay, cool, because now we know that we are just good with this thing. So now let's talk about the data transformation. So far we have ingested the data, we have seen some patterns, stream ingestion, batch ingestion, ETL, ELTL, big data, so many things. Now finally let's talk about the data transformations. So let's say you are ingesting data from so many sources. Let's say there are these many sources. Wow. So now, being a data engineer, one of the core things that we need to do is data transformation. And why? You will understand it. So let's say you have these many sources. Cool. Yes. Now you, or not you, our bit 2. Bit 2 needs to serve the data to the users. These users. And do you know what? These users want to build or basically take the data driven decisions based on these sources. That is the core requirement. Okay, and the problem is this data is not in a shape, is not in a state which can be used directly by these users. Why? Because data is not cleaned. There can be so many nulls, there can be like so many duplicates, there can be like so many garbage data, and the data would not be consolidated. The data would not be you can say combined with all of the necessary sources, because they want easy access. They do not want to, or they cannot actually jump between so many sources, because their role is different. Their role is actually to take decisions. Your role is to make them to take decisions. I hope this step is clear. So perfect. So before these people come into the picture, bit 2 will come into the picture. Bit 2 will say, bro, I will just work with these sources, you just stay back for a time. Perfect. So now bit 2 will use all of these data and transform it. But how? Before talking about how, you first need to understand what. So here, what we discussed, first of all, there can be duplicates, there can be so many joins, there can be so many let's say nulls, you can say garbage data. That garbage data means the data which is not required actually. There can be like some guardrails that you can simply ignore, right? There can be some quality checks as well for your source, because the thing is, you are feeding this data to your downstream solutions or to your downstream stakeholders. You need to make sure that your data has passed all of the quality checks. Otherwise, you cannot feed that data into your downstream. Otherwise, it can break the things. So you can just add all of these things before actually pass this data to the users, or basically to your downstream. Cool. Now the thing is, in order to perform these transformations, and this is just, you can say, 1% of it, like we can have so many other things. And here I also want to talk about one misconception in the data engineering domain. You, or basically bit 2 or data engineer, is not like the person who will always transform the data, bro. This data, okay, this data can have some problems, but not every time. And to be honest, when you are ingesting the data from the sources like database, that data will obviously be very, very clean. Do you know why? Because it is common sense that whenever someone stored the data in the database, this person would have followed the principles like normalization, and obviously all of the constraints that are applied on the database, like primary key, foreign key, not null, unique, first normal form, second normal form, third normal form. So that means like your role is over if you are not transforming the data. Not actually. So this is a misconception that data engineering is all about dealing with messy data sets. No, data engineering is all about dealing with the data. Is about building the data solutions. It's not about just, you can say, transforming messy data sets. There was a time when when it was all about like transforming the data, but now we have so many quality checks enabled on the source side as well. There are like so many good services like event hubs. There are so many services which take care of all those things. Makes sense? Now you're not just like ingesting the data every time from the raw JSON APIs. Not the case right now. There are so many like middle layers that are added. Okay, so this is data transformation. Now we are talking about transforming big data. Cool. Ansh, Lamba, how we can actually transform the data? First of all, tell me, whenever you want to change something, because transformation is what you want to change something. So let's say you have a table. Okay, you have this table, or let's say any kind of data set. Perfect. And this has some problems, right? And you want to transform it. So how you can just do that? If you have some familiarity with some Python libraries, let's say if you want to use Python, you would know that there is a very popular library called pandas, right? So you can use pandas, not a big deal, in order to transform the data. There is one more library, or let's say a kind of solution that we have, polars. Do we have logo? No. Okay, forget about it. Just keep pandas, because pandas is like actually very popular. So pandas can be used to transform your data, where you can just create a data frame on top of your data. Let's say this is your data frame, and then you can just perform all of the transformations you want. You can just clean the data, and then you can just write this data in the form of, let's say, big data formats like Parquet. Do we have Parquet? Wow, bro, you don't even have the file formats. Let's pick this one. Let's say this is a Parquet file. If you do not know about Parquet file, do not worry. We will just discuss this as well. So let's talk about what is a Parquet file, because I told you that I want to work with big data. The thing is, there are two types of file formats. One is columnar based and second is row based. The thing is, when you just work with row based data or row based file formats, your data will be saved row by row. Okay. When you work with columnar based, then your data is saved as column by column. What is the advantage here? Let's talk about it. So let's say you want to perform faster writes. You want to quickly update the data. You want to quickly you can say update a specific record. Then you simply go with this one, row by row. Why? Because here the data is saved in the form of rows. Like your first row will be saved, let's say ID, and then name, let's say then email. Okay, and here one name is ABC, this is let's say XYZ, then 2, then let's say DEF, then let's say email is DF. Simple. So your data in the row by row will be saved as like this, 1 ABC, then XYZ, then this will be like your first block. Okay, perfect. And then similarly you will be having second, DF and DF. Perfect. So now what will happen? Let's say I want to make a change in a row. I can quickly come here at this block and I can immediately change the entire row. Why? Because all the content of that row will be saved together. Perfect. So this is picked when you want to perform quick writes and DML. Okay. But here columnar based is a choice that we want to make in the big data. Why? Because in the big data, or being a data engineer, we want to quickly read the data and we want to save some cost. Because if let's say, or let's keep it, let's say this is our raw based. Okay, let's say row based. Perfect. Or let's move it from here. Perfect. So this is your row based. Simple. Now what will happen? You can actually read this data. There is no problem with it. But when I want to write the same data in the columnar format, so entire column will be saved together. Let's say 1, 2. Okay, this is my first block. Then there will be like ABC, then DEF. Then I will be having XYZ and then DEF. Simple. Now what will happen? Now each column is saved together. Okay, makes sense. Let's say 1, then 2, then 3. Perfect. Now the issue is, or let's say the benefit that I'm just getting, now if I just, let's say, query something, let's say select, I just want to select, let's say, ID and name, right, from table. Because in the big data, we just prefer like picking the entire columns. We do not like write much filters. So I just want to pick ID and name. If I run this query on this particular format, just tell me one thing. Will I see quick data retrieval? The answer is yes, because this ID is here and the entire content of that particular column is together. And then this one. And if I run this same query on top of this one, on top of this particular one, I will have to scan all of the data. Why? Because my this column, this first column, which is ID, is distributed among all of the records. That is the difference. So here we get a performance because here we can perform something called as data skipping. We do not need to read all of the data. Perfect. And yes, this is used for data quick writing, data reading, because we cannot quickly write the data. But it doesn't mean like it is very slow. Not really. We have some like optimization as well. So this is the basic idea between row based and column based. I hope it makes sense. Cool. So here I will pick the Parquet format because I just need to tell you that why Parquet file, not just like, okay, we will just pick Parquet file. Why? I don't know, but just pick Parquet file. So now you know why Parquet file. Cool. Now the thing is, this particular solution can work for your small data sets, but not for your big data sets, or basically big data frames. Why? Because as you know that this particular thing can work on one machine, right? This can work on one machine. You can install pandas, you can install polars, you can install Python, anything, and you can work with it, right? But here, as I just told you, that we work with big data, where we have like so much of data that it is being shared between so many machines, and you do not actually need to worry about why it is shared and is it shared or not. But you are working with big data, you are working with so much of data, a single machine cannot handle it, right? Agree with me? Let's say you have here 10 terabytes of data. Can you just process this data with one machine? Possibly yes, but it will take a lot of time. Let's say you want to process 10 terabyte of data as soon as possible. Then you have two choices. Okay, let's talk about those two choices. The first choice is vertical scaling. Cool. Here you will simply pick one machine. Let's say your one machine, and you will increase the size of it. Cool. So let's say currently it has 4 GB of RAM and let's say 8 cores and blah 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 and you are using this thing, right? You want to process more data. What you can do, you can increase its power, you can add more RAM, and you can do more stuff. It still works, and it was working since I would say past few decades. It was working like fine, but here we do not get high availability, right? No high availability, right? No fault tolerance. Why? Because let's say you are processing this data in this machine and it works fine, perfect. And let's say you are just using your pandas or whatever you want to use. You are simply using one machine. Now the thing is, let's say this machine goes down because obviously this is a technical machine, this can go down, right? This machine is not working. Now just perform your processing. You will say, bro, wait, let me just spin up a new machine so that I can just do it. So it will take a lot of time. Second, you have to pay a lot of cost as well to perform this thing. Why? Because you need to keep this machine up and running even if you are not processing much data. For example, let's say you were processing a lot of data. So let's bring a lot of data. So let's say this much. Okay. And for a few months it was working fine. But now suddenly data size is this much. Now you still need to use this machine in order to process this machine, this much of data. Is it a good thing? No. So you do not get the opportunity to scale it down. Obviously, because see, some people will say, bro, just create a new machine. Yeah, I can just do that. But then what will happen? What will happen? I would just create a new more virtual machine and I would need to just dump it again. And then let's say tomorrow I have just like more data. So I cannot just do this thing again and again. Here comes the concept of horizontal scaling. And there are like so many downsides of vertical scaling as well. Like you can just imagine anything. Let's say the server is not working, there's a technical glitch, there is like a kind of server failure. What will you do? When we just go with horizontal scaling, or you can say a very popular name in the software engineering is distributed computing, which is actually the most important stuff happened in this, you can say, era, in this decade or in the last decade. Distributed computing actually changed everything. So here we do not just bring this one big computer, or let's say server, or let's say VM, node, whatever you want to say. Here we bring a cluster of machines and we connect them together and we work together. Now here the opportunity is we can just scale as many machines as you want, see, and we can just remove as many machines as we want whenever we want. Here we do not need to worry about anything, and here we get high availability and obviously better fault tolerance, and we get speed. That is the main thing. So now if I want to process this data frame, this one, perfect. So what I can do, I can literally take this data frame and I can just provide this data set to these machines, and then I can just transform the data because I can distribute this data frame. Understand the flow. See, this is my data frame. I will break this data frame in small chunks and each machine will process it. Simple, like this. Okay. This is called your distributed computing, or basically distributed processing. And then they will work together to actually perform this stuff, and then you will see your, let's say, result, transform data, whatever you want to do. I hope it makes sense. This is the flow. Okay, this is your distributed transformation. Cool, perfect. And this is the standard right now. Now, in order to perform this distributed transformation, we had a very popular, you can say, framework that you were using before. It's called Apache Hadoop MapReduce. So Hadoop is actually a kind of a complete ecosystem. Within this, we have MapReduce, HDFS, and so many other things. But yeah, MapReduce was like one of the most popular frameworks that we were using, okay, in order to perform Hadoop. But nowadays, we do not hear much about MapReduce, or basically Hadoop MapReduce. Why? Because now we use something called as Apache Spark, and you would also have heard about this thing, Apache Spark. Both are distributed frameworks, first of all. Okay, both perform the same thing. Then why, Ansh, Lamba, this one and why not this one? So this was actually came before, okay, and this was came in, I think, 2009 or 10. Yeah. So the problem with this Hadoop was this was performing this thing nicely, but this was writing the intermediate results into the disk, and reading the data from the disk again and again was an expensive task. So that's why we started processing our data in the RAM, in the memory itself. So it boosted the performance. This was the major difference. Okay, major. Obviously, then Spark got funding. They just started Databricks. Then they just did so many optimization and keep on just doing the stuff because they had the money and everything was good. But this was the major difference between Apache Spark and Hadoop. And I think this was started as a research project in UC Berkeley by Ali Gotsi and his team. So they just started then Apache Spark, and then they just monetized it with Databricks. Simple. So this was the major difference. But the concept is distributed transformation, which performed your transformation using multiple machines together. Make sense? Cool. And both are, I think, open source, so you do not need to actually worry. And along with this Apache Spark, we have one more player in the market, which is not very popular, but still very popular. It's called Trino. Trino was earlier known as Presto SQL, and this is also a kind of distributed SQL engine which performs your transformations using distributed computing. And yes, it is also open source. Yes. And it is, I think, a very popular choice with AWS tag, but people prefer Spark nowadays. So yeah, Spark has become the standard. So this is your data transformation. I hope it makes sense. Cool. Very good. Now, a very quick question that I have right now. We understood about data transformation. We understood like these frameworks, why, and everything. Remember, we just talked about data ingestion. Yeah, we talked about it. And we talked about batch ingestion and stream ingestion. Cool. So tell me one thing. If I am performing batch ingestion, my transformation will also become batch transformation. Common sense. And if I'm just performing stream ingestion, my transformation will also become stream transformation. Oh, so both will be different. Yes. So here under transformation, we have actually two types. Okay. The one is your batch transformation and the other is stream transformation. And this goes with batch ingestion, this goes with stream ingestion. Simple, and that makes sense. So here are the things. So now Ansh, Lamba, how we can just perform batch and stream. So you will be very happy to know this thing. Apache Spark is actually compatible with both. That is another reason why we use Apache Spark nowadays, because we do not need to change our code. We do not need to change anything. We get compatibility to all of the APIs within Apache Spark with both batch and streaming both. Wow. Yes, this is one of the major things. But yes, in the stream ingestion, stream transformation, we have amazing players in the market like Flink. Apache Flink is very popular framework that we have for stream ingestion, or basically stream transformation. And I think there are more, but these two are the most popular nowadays, and both are open source. So here we have Spark structured streaming, which is nothing but the part of your Apache Spark. And this is Apache Flink, created dedicatedly for stream transformation. But to be honest, Apache Spark is actually leading the curve for the data engineering, because you do not need to include more and more frameworks. You can just work with one. Cool. So this is your data transformation. I hope this would have given you now a very good picture around why people are talking about Apache Spark, why people are talking about distributed computing, data engineering, and blah, blah, blah. Cool. Very good. I'm happy that now you are able to connect the dots, and now you have a very clear picture of data engineering in your mind. And that is the intent of this video, to be honest. Okay. That is the only intent, just to help you so that you have a clear understanding of all of those jargons and whatever that you had in your mind. Now everything will be like crystal clear. Now I want to talk about data storage, because we talked about ingestion, we talked about transformation. But Ansh, Lamba, we also talked about data storage, right? We just talked about data lake. Yes, we talked about data lake, a very little information on data lake, but now we need to talk about on it in detail, because it is not the only solution that we are using right now, or this is not how we are using it right now. So data storage, as we know that either we are performing ETL or ELT, we need data storage. But with ETL, we know that we should just store our data in the databases or any lightweight storage. But with big data, we store our data in the data lakes. That is for sure, right? That is for sure. So that means, Ansh, Lamba, data lakes have become the standard. Yes, you can just say that data lakes are the standard. That is why now every data engineering solution is using data lakes. Every data engineering solution. But you know what? Data lake actually didn't solve our problem. Really? Yeah. Let me just talk about that. Basically, before data lakes, let me just show the entire life cycle. First of all, we had something called as data warehouse. Okay. Data warehouse. Let's take this one. This looks good. Data warehouse. What is this thing? Warehouse is just, you can say, stored in database. First of all, yeah, it is stored in database, still in your traditional database, but with some optimizations for reads, some, you can say, better aggregations for your reads, and all of these things. And we will just talk about data warehouse, or basically modeling techniques, later in this video. But you can just imagine that this was stored in your traditional databases. Okay. And this was your data warehouse. Cool. Good. Now this was a warehouse, and we know that this didn't actually solve all of the problems. Why? Because volume, variety, veracity, velocity, and V, so many V's. Now the thing is, this problem was solved by data lake, as we know. Cool. That means everything is good, right? Not really. So this was replaced by data lake, or not replaced. This was added in the domain data lakes. But you know what? There are two major consumers of our data lakes, or basically the data that we prepare, that we data engineers prepare. One is analytics team. So let's say reporting team. Do we have reporting? Let's bring Power BI if we have. Yeah, we have Power BI. Cool. So let's say one team is your reporting team, where you are just reporting on the data. The second thing is, or second team is your data science team. Let's say where they are just creating the models or anything. Okay, cool. So this was a second team. Now this team, this models team was very happy. Why? Because modeling or data science team just uses the raw files which is stored in your data lake. Okay, but Power BI, or basically reporting team, because Power BI actually came very late. I'm just taking any reporting example. Okay, so let me just remove it, because I know you will say, bro, Power BI just came few years back. Okay, you are right, let's take this report. So let's say reporting. So now the thing is, reporting needs performance, because your dashboards are being refreshed using that data. So they need a very strong performance here. They cannot negotiate on that. But here the data science team actually does not worry about your data modeling. They can, but sometimes they just want the raw data, and they just create or curate their data sets on their own, whatever they just want to, because they just want data dumps. Okay, most of the time. So now the thing was, this team was very happy, and this team was not happy. Why? Because with the data lakes, we know that we have just files. We do not have any kind of modeling, right? These are just files. So we were not able to provide that much of performance. So now what happened? People were creating duplicate layers, like they were using data lakes as well, and they were recreating this data warehouse in between this layer. Oh, because they didn't want to directly connect to this data lake, so they just added another layer for this warehouse. Are you getting my point? Like, this was already outdated. Okay, but after the data lake, this started happening. Oh, okay. So this was a lineage. So let's say it was in 1980s. This would be in, let's say, early 2000s. Okay, so this was the era. Cool. So let me just remove this arrow. So this was the lineage. So here people were still started creating their own little data warehouses, which actually led to a bigger problem, because this layer was not totally replaced, and this led to creation of so many independent data warehouses just for that report, which actually didn't make any sense. Then comes the concept of data lakehouse, and this changed the dynamics of the data engineering industry. Really? Yes, sir. Yes, lakehouse. What is this lakehouse? Just look at this word. This word is made up of two things, and you know that: data lake and warehouse. Data lake plus warehouse. So we said that, see, we want to save our data in data lake, that is for sure, because it is cheap, it can handle all of the data, and data science team is already very happy. So we just need to add the data warehouse performance on top of our data lake. Can we add that? Some people said yes, we can add that. We can just add data warehousing capabilities on top of our data lake, and that way we will be able to provide best performance to this reporting team. And then some people created the concept called Lakehouse, and I think the same team which created who created the Apache Spark, they created this concept Lakehouse. So they simply said, see, we can create a kind of concept called Lakehouse which will provide you warehouse capabilities on top of your data. But how? Okay, let's talk about it. So let's say your data is stored in the data lake. Cool. And you have, let's say, files. Let's bring one file. So this is your data, and which format we pick usually? Parquet, right? So let's say data dot Parquet. Cool. Data dot Parquet. This is my file. Okay. Now I do not have any kind of database here. Obviously, I do not have any kind of database powers. I cannot perform something called as ACID properties, atomicity, consistency, isolation, durability, right? Nothing. I cannot perform commits and rollbacks. Nothing. I do not have anything, right? Wow, rollbacks. I cannot perform any kind of indexing. I do not have schema on write. Like it should just make sure that schema is not broken. So I didn't even have these much of basic things that I was just expecting from any data warehouse, right? So then Lakehouse came into the picture, and Lakehouse team said, so see, you have the file in Parquet format, very good. We will introduce something called as Delta Lake. Now Ansh Lamba, what is this thing Delta Lake? So let's talk about it. Don't worry, don't. Everything is like discussed, okay? So do not worry. So this is Delta Lake, and Delta Lake is the backbone of this Lakehouse architecture. So, and what is so special? First of all, forget about Delta Lake. This team said we will introduce something called as open table format. Okay. What is open table format? Open table format says your data will remain the same. We will add one folder on top of it. And this folder is special because this is a kind of transactional log. So let's bring folder. So let's say this is your folder. So they will create a folder, okay, for you along with your data. And this will be a logs folder. Cool. Let's say log. Perfect. And when you combine this thing, this becomes your Lakehouse. What? Are you serious? Yes. Let me explain. This is a very detailed topic. So the thing is, what is so special here in this folder that it makes your normal data lake into a Lakehouse? Okay. Data is here, right? And we were not able to see the performance with your data regarding those asset compatibilities or anything, right? This log came into the picture, and this log said, I will perform all of those things that a database should perform. This log actually stores all of the transactions, or you can say transactions metadata. Let's say you added anything. Let's say you added some data. So this information will be stored here in the logs folder. Okay. Everything will be stored here. Everything. Let's say you removed some data. That data will also be saved here. Okay. Like any information that you want for your data will be saved here in this logs folder. And here, not even just a Lakehouse, because see, let's create another copy. So let's say this was before Lakehouse, and let's bring it here. Perfect. So this was, let's say, before Lakehouse, so that you can just see the things parallelly. So see, this was before Lakehouse, and you were still having engines like, let's say, Trino, Spark, all of these things. Okay. So let's say this is your Trino engine, Spark. So you were still running queries on top of this data, which is just a data lake before Lakehouse. Okay, before Lakehouse. So let me just write before Lakehouse. So this was still possible. This was still possible. Okay, so this was already there. But now, after the Lakehouse, what will be the flow? So now, you would have guessed it. So now this will not directly read your data, read your Parquet files. No, this will now go through this particular flow. So it will first of all read this particular metadata folder. Then it will just tell this, because in this log you will have everything, like which data Parquet file to add, which data Parquet file to remove, what is the schema, everything. Then it will just read the data files, and then it will just give you the results. And it is a better approach because you get all of the, you can say, powers of a traditional database with this kind of delta log, with this transaction log alone. This is the backbone of your Lakehouse architecture. Right? So there is a misconception that Lakehouse means data lake, that data is stored in the data lake, and your warehouse engine is decoupled, right? Like this. But it is not true, because this thing was already there before Lakehouse. We were having data in the data lake, and we were having an engine, Spark engine, to read the data. It was still there. But after Lakehouse, we got this open table format, which is a delta lake. This concept is delta lake, or you can say delta format. This is your open table format. See this thing, okay? This is your delta lake or delta format, because do not get confused, it is not a storage layer, it is just an architecture. But I know the name is a little bit confusing. So this is your delta lake, delta format, or basically open table format. Let's keep it, let's say, open table format. because we have Delta Lake, we have Apache Iceberg, Apache Hoodie. Like these three are the open table formats. So this is your Lakehouse. Now your engine is same. Now you have the same engine. See, this Spark engine was already there before Lakehouse as well. But this time you have this special folder called transaction log, and this adds the warehousing capabilities because now you can perform ACID. Now you can just perform your commits, rollbacks, time traveling, everything is possible. And obviously schema on writes. Now you can just throw some errors before messing with the schema. So you have all of those opportunities with this particular concept. That is why I told you Lakehouse is nothing without open table format. Open table format is the backbone of Lakehouse. I hope this concept is clear, because this is one of the most important concept, because this is one of the most recent advancements that we have in the data engineering. Because Lakehouse was introduced, I think, just few years back. It was not there before. So that is all about your Lakehouse, data storage and everything. So this is a kind of complete picture that you need to understand, because now you have ingested the data, you have transformed the data, you have stored the data, you have covered like distributed transformation, everything. Now the final thing, not the final thing, but the thing that we actually perform a lot of times, okay, but at the end, it's called data orchestration. Let's talk about this thing, data orchestration. Data orchestration is one of the most important pillars of data engineering. Why? Because oftentimes we need to perform repetition, or basically you can say automation. Okay, let's say you are building the end-to-end data solution, and let's say you are ingesting the data from so many sources, let's say, okay, and then you are, let's say, transforming the data. Let's use some real example so that you can just understand it. So let's say you have sources like this. These are the sources. Perfect. And you want to perform this thing, like ingest this data. Cool. So simply say ingest. Okay. Now after ingestion, you will transform this data. So let's say you are using Spark or Trino, anything. Spark. Perfect. And then you are, let's say, dumping this, or basically creating the lakehouse in your data lake. Let's say this is your transform, and then not directly transform, because now you are aware of ELTL, so I can just add it here as well. So let's say data lake, or let's say ADL is gen 2. Let's pick S3, it's fine. Perfect. So let's say this is the second task, ingesting, loading it here, and performing the stuff transformation. And after transformation, you are simply creating, let's say, a kind of lakehouse. And for that, you can just pick any data storage location. It can be a S3, or it can be a Databricks as well connected with S3. So let's pick Databricks. Cool. Now do not get confused. Databricks is just, you can say, the managed layer for your Apache Spark, and with the course of time it has built amazing lakehouse capabilities on top of your normal data lake. So that is why in the industry we use Databricks to serve our data, basically the final layer. But yes, under the hood, Databricks is not storing your data. Databricks data is also stored in the S3 bucket, basically in the data lake. So it is not actually storing anything, it is simply processing your data, but with amazing compatibilities with your lakehouse and everything. So many optimization, amazing stuff. So this is the flow. Now you will tell me, I have built this solution. Cool. Okay. Who will run this solution every single day? Or forget about every single day. I want to run it, let's say, every hour. Who will do that? Who will? You will say, yeah, I can just do that. I have a lot of time. I can just click on one button, run, and I can just do it. Okay, cool. Very good. Let's say I have hundreds of pipelines like this. Oh, yeah. And forget about hundreds of pipelines. Let's say this is like one example. In the second example, I am using this pipeline, this complete solution, as my source for another pipeline. Let's say this is my pipeline number 1, and I want to run the entire pipeline as my first task, and then I have, let's say, another pipeline with the dependency like this. Okay, it can happen. Cool. Let's say pipeline 1, pipeline 2. Okay. And you can even have like pipeline 3, 4, 5, so many. So there are so many tasks, right? So many inner tasks. Who will take care of this thing? Bit 2. Bit 2 will take care of this thing, bro. So bit 2 data engineer needs to take care of this thing. This is the core thing that we need to do or data engineers need to do. So this concept is called data orchestration, where you are orchestrating your solution. If you have ever seen any orchestrator, okay, any orchestrator, orchestration is actually a musical word where a person simply swings the sticks just to orchestrate the instruments, right? Here we use data orchestration word because you are orchestrating or basically aligning all of the pieces together to run in the exact order. Because you cannot just transform the data before loading it somewhere or before, let's say, ingesting it. That doesn't make any sense, right? So you need to make sure that particular thing. And you create the entire dependency flow, entire automation by yourself. Okay, cool. So this is the data orchestration. Now, in order to perform this thing, how would you just do that? If I just ask you, like, how would you do that? One person can say, I can write one Python script. That's actually a very good answer because we were writing these scripts just to automate everything, right? You can just create Python scripts. Some people will say, I can just write bash script or PowerShell script. Do we have PowerShell, bro? Yeah. Some people say I can just write PowerShell script where I can just connect all of these things through APIs and I can just define the dependency. That's actually correct, by the way, technically correct, logically correct, but practically is not correct. Why? Because see, you will just write a script. Let's say you have prepared one script. Code. Perfect. Let's take this one. Let's say you have defined one script like this. Perfect. This is your script. You can run this, it's fine. But let's say only and only this task fails. Let's say only this task failed. Okay. Now, how I would know that this task failed? How I would know? Because in the code, I cannot actually see the DAG. What is DAG? Directed acyclic graph. So whenever we just create any kind of data orchestration or any kind of pipeline, we always create a DAG. So remember this thing, directed acyclic graph. Directed means it has a dedicated order. Okay, it has a dedicated your direction in which direction it should just run. So this is the direction from this to this, right? Directed. What is acyclic? You cannot run anything in the loop. Let's say like this. You cannot do it like this. It will be like infinitely running, right? This will create an infinite loop. So your DAG should always be acyclic. And graph is graph. This is a graph. This is a graph. This is a graph. So you create a DAG. So just tell me one thing, when you will write the code for this DAG in your just normal Python script or let's say bash script or let's say PowerShell script, how I would be able to debug these things easily? Because data engineering workloads require only 50% of the time in building. Rest of the 50% is just debugging the existing solutions and improving those, obviously. This is the harsh reality, right? It is not just about development. Data engineering role is actually very different. Okay. So now here, you need to debug these things as well. Just you tell me, can you just debug a code? Can you? Not actually, bro. So here comes the concept of data orchestration tools. Now we have amazing data orchestration tools available. For example, very popular Airflow, Apache Airflow. Again, open source, free Apache, you can say data orchestration framework available. Second thing, you can use Daxter if you want to use. Daxter is actually a very popular one. Daxter is there, then Data Factory, like cloud solutions are obviously there. So these are like very popular solutions. Let's keep Airflow because Airflow is a standard that we use in data engineering. So we can use Apache Airflow to create the DAGs with visuals. We can have, let's say, task, right? We can have, let's say, task like this. Wow. Let me show you just a quick demo. Not a demo. Let me show you an image of, you can say DAGs, so how we just see it. Let me just bring Apache Airflow DAG. You will have like a visual. So let me just see in the official documentation. So see, so this can convert your code like this. Now just tell me one thing, is it easy to debug this, or is it easy to debug a script which is like written like this? Obviously this, bro. So do you know how it will just work? You will simply write a script, obviously a Python script. Then it will convert that Python script into this tag. And obviously not just Python, because we have Apache Airflow framework in itself. But yes, it is very Pythonic. You just need to write 90% of your code in Python, and rest of the 10% will be like just decorators and some modules created by Apache Airflow. Simple. So you just create the tag like this. Wow. So here you can see if the task is succeeded, and obviously not just about tag. Here you can first of all schedule this particular thing just to run, let's say every hour. Then you can even add some retry policies. Let's say this task is failed, so you can just simply add retry. Let's say this task is like, you can just think about it. Just imagine that you have a very complex control flow. That means, let's say this task should run, and this task should run, and this task should run, and only then this task should run. These both should be completed. So if you have like a very complex control flow, you cannot just debug the code very easily, and you cannot even write the best Python script for that control flow. So here in the modules like Apache Airflow, basically frameworks like Apache Airflow, you get all of these things out of the box, and it does everything for you. Wow, it maintains the state for you. So Apache Airflow is one of the best data orchestration framework, and that is why in every job description of data engineering you will see Apache Airflow for sure. For sure. Makes sense. So now I think you see, this is the code. Like code looks like this. So you just write code like this. It is like very Pythonic. You simply use the decorators because task flow APIs are like very Pythonic. So it is not actually a very big deal to learn if you already know Python. Oh, but now you know why you are learning this thing. It's not just about learning that thing because it is written in the job description. Not really, bro. So now you know how, like, why you need to learn this. So this is like pure code thing. Now there are so many solutions, or I would say most of the solutions in the data orchestration world, which are low no code. Okay. If I just show you, let's say Daxter, I think it is low no code, and Airtable is also there. So if I just say Daxter DAG, if I just go to images, so you can just create, let's say DAGs like this, using your Daxter. So it is like low no code. There you do not need to just write Python code or any kind of code which is related to your tasks, but it is a personal choice. And to be honest, Apache Airflow is like widely used. It is open source, so that is why still people learn Apache Airflow, because it makes sense. Because when you just need to perform so many advanced and complex control flows, and I would say even in this AI world, you need to perform a lot of custom API calls and everything. So I think that makes sense if you just learn Apache Airflow, according to my perspective. Cool. This is your Apache Airflow, and I hope now you have like clear understanding why do we use Apache Airflow for data orchestration. So now let's talk about the layer which is finally consumed by the, you can say, business stakeholders, reporting team and everything. So remember when we just stored our data in the Lakehouse, right? So this was the layer that were being used by these people, reporting team and everything, right? But we do not directly send the data. We do not just provide the data as it is. Not really. We perform something called as data modeling. And I know that a lot of people were waiting for this thing, data modeling, because this is so important. But here you need to understand some concepts. Why? Because see, data modeling has so many colors. Data modeling has so many, you can say, versions. So here the major two ones are OLTP and OLAP. Okay, let's say OLTP and OLAP. We'll cover both, don't worry. So OLTP modeling is the modeling that we perform with your databases. Okay, remember this thing. Okay, database. And here this particular data modeling is done to make sure that you can quickly write the data as soon as possible. Okay, and here you perform something called as normalization, post normal form, second normal form, third normal form, like everything. You will simply add some constraints. You will make sure the data is normalized, constraints, rules, everything. Makes sense. And if you have like heard about those normal forms, then it's good. Otherwise, it's not a big deal. Basically, you need to understand like data should be normalized. And third normal form is the standard. You can also say BCNF is the standard. And after that, we do not need to worry. But the thing is, OLTP database modeling is yes important for data engineers. But if you will ask me the proportion, it is just, I would say, 30% or even 20%. 20%, 80% is this one. And I want to ask you, why is this the case? Because this data model will be prepared more by the data, or you can say not by data, built by the software engineers. Okay, in most of the cases. But yes, you still need to have spent 20% of the time in your data base modeling. And here comes the concept of OLAP. OLAP means when you perform the data modeling on the, you can say, your warehouse or basically lakehouse. Simple. Okay, cool. So this is the modeling that you perform here in the lakehouse and the at the serving layer here. Oh, so this Spark does not just directly read your Parquet files. Not exactly. We provide the entire data model so that we can efficiently read the data, and obviously all of the benefits that we get with any data modeling technique. So we need to just provide all of these things. So here you do not save your normalized data, you simply create denormalized data. But denormalized word is not correct, because yes, we still normalize our data but not completely. So you can say hybrid normalization, because still we have like dedicated tables, so it's not like completely denormalized, it's not like that. But yeah, and here we do not worry much about the constraints, but yes, with the course of time we have some constraints as well, so that is fine. Make sense? Cool. So now what is the like meaning of OLTP? OLTP first of all means online transactional processing. Cool. And this means online analytical processing. As the name suggests, this particular modeling is for transactions where you just need to save the transaction as quickly as possible. This particular modeling is performed for your analytics. Let's say you want to perform any kind of reporting, any kind of analytics on top of this particular model, because you cannot perform reporting directly on this thing. And I will just ask you why. Because this particular database is not compatible with those things. This database is not, or basically this engine is not compatible to return, let's say, millions or billions of records. This engine is compatible to quickly write data as soon as possible. And this database engine, or basically warehouse engine, is compatible to return millions or billions of records, just to even, let's say, return all the data in one go. Wow. So that is why we always go with OLAP. Now, when we just want to go with OLAP, there is a dedicated modeling technique that we follow, like similar to normalization, because here we perform first normal form, second normal form, third normal form, right? And here we have like special technique. It's called dimensional data model, or basically dimensional data modeling. And this was developed by your Ralph Kimball in 1980s, I guess. And this is not the only data modeling technique. There are like so many, let's say, data vault nowadays are very popular. Inmon's data model, like there are like so many. So you can just go with those data modeling techniques. I can even show you if I get any good resource. Let me just get data modeling techniques for data warehouse. Perfect. So let me just bring it here. Let's see if we get anything. Data vault, yeah, data vault is there. Where is Inmon data model? Okay, so see, Inmon data model introduced by Bill Inmon is a top-down approach to design a data warehouse. It begins with creating comprehensive corporate data model, and to be honest, Inmon's data model is not very, you can say, popular in the on the data engineering side, or basically on the OLAP side, but yes, it is still used. Okay, so in this approach, the data warehouse is built in a normalized form, so it is not like very denormalized. Oh, so that is why it goes hand in hand with your normal traditional first normal form, second normal form, but not actually exactly like this. So see, it is built in a normalized form, typically third normal form, which minimizes the redundancy and ensures data consistency across the organization. This central repository stores detailed atomic level, which can be then used to create data marts. What are data marts? We'll talk about it, do not worry. So yes, there are so many like data modeling techniques that we use on the OLAP side, but on the OLTP side, it's just one. But with OLAP, we have like so many. We have data vault as well. So there are so many options available. But this is the technique which is the backbone right now and which is being used in your almost all of the solutions. Dimensional data model. Let's talk about dimensional data model then. Let's put some light on this particular thing. So dimensional data modeling technique is the modeling technique where you create fact and dimension tables. What are these things? So basically, let's say you have your table. Let's say you have this table, and instead of just creating a very big one table, you simply break this table into fact and dimension table. So what this will become, this will be converted into, let's say, something like this. There'll be like one fact table in the middle, or not in the middle basically, but yeah, from the graphic point of view, in the middle is the fact table. Then you have, let's say, dimension tables. Let's say this is one dimension table, this is one dimension table, and so many. You can even have like more than one fact table, but let's say this is our way to create it. Perfect. So what is so special in this fact and dimension tables, and what is this thing? Concept is very simple. Let's try to understand it, because obviously data modeling is a detailed topic in itself, but still we need to understand a little bit of it. So basically, in the fact table, you will simply store all of the numbers, or basically the aggregatables that you just aggregate to build some KPIs. Let's say amount, sales amount, order amount, let's say distance, kilometers, like it depends like which solution you are building. So all of the aggregatables will be stored in the fact table, and all of the context will be stored in the dimension table. Now what context? Let's say you want to find how many sales that you have made so far. So all that information will be stored in the fact, right? But now you want to figure out how many customers, or basically you want to find how many sales you have made in each region. So region context will come from dimension table. So that is why it is called as, it provides context to your data model. And here you do not save any aggregatable. Here you do not save any numbers that you use for aggregations or building some KPIs. Here you will only use the columns which you use to provide context or perform grouping. Let's say group by column on customer ID, customer name, region, all of these things. Oh, and this is one of the best dimension data model, which is very performant with big data, and it has actually proved, because see, it was introduced in 1980s, okay, and it is still used even after 45 years. So obviously it would have achieved something really big that we are still using it after 45 years. It's not a small thing that you introduce something and it is still being used. Especially the concept, not just an engine or anything, just a concept. We still create same dimensional data model that we were creating in 1980s. Same, ditto same. Those are the rules we still follow. So you can just think about it, like how compatible will it be? And yes, nowadays we are receiving more and more demand on the data vault side, but this is still the backbone. This is still the backbone. Make sense? And within the dimensional data model, here we also deal with something called as slowly changing dimensions. And you would also have heard about this thing. So I thought of adding this thing as well in this particular masterclass. So what are slowly changing dimensions? Why every data engineer is talking about slowly changing dimension? Basically, let's say you are just storing dimension here, right? Basically, facts never change. So fact table is fine. You will simply create a table which will be keep on appending the new records. But dimension table can be changed. How? Let me just ask you a simple question. Let's say your name is Bittu, and tomorrow your name is Bunty. Now you will say, who will change the name? There are so many people who change their names. Let's say your name is Bittu and your surname is something, right? And now after something, you just renamed your surname to something else, right? So in those scenarios, let's say you just changed your address, you just changed some information in your personal anything like personal, then in that scenario you would need to reflect that change in your dimension table. I hope it makes sense. So how will you do that? That particular thing is, you can say, bucketed under this concept, slowly changing dimensions. So we have multiple types. The first type is type 0. What? Yeah. Type 0 says we are assuming that you will never have changes in your information. That is, yes, very, you can say, rare case, edge case. So yeah. Then we have type 1. Type 1 says, I will literally make the changes in place. So let me just explain this concept with the help of a very good Wikipedia page. Slowly changing dimensions. Perfect. Yeah, here it is. Let me just bring it here. So this is the type 1. So let's say you were having this table where the supplier name was Acme Supply Company and supplier state was California. Okay, and this was a supplier key. And this is our dimension table. After some time, the supplier's state is changed to Illinois. Okay, now you will directly override this thing in the table. Oh, yes, this is your type 1. Then this is a very good solution, by the way, and I would say more than half of the solutions are still using type 1 for slowly changing dimension, but this does not enable all of the things that we need to do in data engineering. Why? Because let's say I want to find the previous state as well. What was the previous state? So how I would just see it, because it has changed, right? So here comes the concept of type 2. When we need to retain the history, complete history of our table, we simply create a new row. So see, earlier we were having California as our state, and this time we have version 1 for our state. Oh, and whenever I will be just trying to query this particular table, I will only see the version 1, which is the latest version, but I will have the option to go back to the previous version. This way I can maintain the entire history of the table. And this is this is the one way of actually creating it, and this is the another way where they just use the date column, start date and end date. But you do not actually need to worry about that thing, because there is a dedicated you can say area within itself when we just talk about dimensional data modeling or data modeling for data engineering. Here you are simply understanding the overview of it. Cool. So the next one is type 2. We have so many types. We have till type 6, but these are the two only types that we use in the industry most of the time. In the type 3, we simply add a new attribute, which is of no use, I would say. Then in type 4, we just combine type 1 and type 2. So these are like just for the, you can say, documentation and for the paperwork. But in reality, we either build type 1 and type 2. That's it. That is it. Okay, cool. So this is all about how we serve our data. So what we will do at the end, we will take this particular data model, and this data model will obviously stored in the data lake. So let's store this thing in the data lake. Let's bring S3, because we know that our data resides in S3. That is for sure. Cool. And yes, this will be having files, right? Because this is just a graphic view, but in reality, this will be a kind of folder with Parquet files, right? And yes, with one open table format as well. So let's say this will be our folder with delta log. Let's call it as, let's say, log, because log table can be for delta, iceberg, anything. And here we will simply create our Parquet files. Cool. Parquet files. So this is this thing, right? And this entire thing is saved inside your S3. I hope it makes sense, right? So let's create a new outer layer here so that you can just understand it. So this is your data model. Make sense? Now what I need to do, I will take this thing and I will say, hey, my data layer is ready. Okay, and you can just build your reports. You can just do anything you want to do. So here, all of the reporting team, all of the Power BI team, anyone like can just build the reports. Any data science team can just build the models, anything. Let's say MCP server, anything. So this is the flow. This is the flow. I hope Now you have clear understanding of everything. Make sense? Cool. So this is the flow. This is the backbone of your serving layer, because without data model, if you just simply serve your folders, still you will not see that much of compatibility with reports, because report needs high performance with your modeling technique. Simple, because it can perform joins better and everything. Cool. So this is your data modeling. Now you will say, Ansh, Lamba, we have also heard about a concept called medallion architecture. Where does that concept fit in this entire thing? Very good question. So data, you can say engineering has a concept called medallion architecture. So as the name suggests, this is not a kind of layer. This is nothing. This is not a technology either. This is a design pattern. So remember, we just ingest the data, we transform the data, we store the data, the final layer. So instead of just building entire thing in different layers, in so many layers, because that can also promote data swarms. So we follow an approach called medallion. So do we have medal? Yeah. So let's say I'll be having one medal for my bronze layer. Okay. Then I will be having one layer for my silver layer. Let's say silver. Then I will be having one layer for gold. Cool. 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 Perfect. What is so special? Like, obviously the names are cool because bronze, silver, gold. So here what we do, in the bronze layer, we perform all of the ingestions. Oh, okay. All of the ingestions, or basically your extraction. So we perform all of the ingestion. Here we perform all of the transformation. Oh, okay. And here we perform, you can just serve your data model, the serving layer, the final layer. Oh, and everything is actually backed by the storage, obviously, because as you know, just that we follow ELTL and we immediately just dump the data now. So this is backed by your data storage. All the layers, bronze, silver, gold. So bronze, silver, gold are actually the layers that we have created inside the S3, or basically your cloud. And these are the, you can say, target. Ingestion is the first target, then transformation, then survey. Simple. Oh, and all of the reporting will connect only to the gold layer. That's the standard. Nowadays people are connecting data directly to the silver layer as well, but obviously they can do whatever they want. But yeah, this is the standard that we just create the gold layer. Okay. And in the gold layer that we have the final data model, right? Cool. So here comes the concept of this medallion architecture. And I hope this is not a big deal now, because now you know all of the fundamentals and this is just another design pattern. Okay, cool. This is everything, by the way, that you need to understand and get started with data engineering, and this is your beginner's guide. Now I just want to take few more minutes just to explain one more concept, because now is the time to talk about it. It's called stack, or let's say cloud stack. Now even a school student would know that all of these solutions are now being built on the cloud directly. And what are the three popular clouds? One is Azure, right? Second is AWS, this one, and third one is GCP. And to be honest, in data engineering world, two are the most popular, Azure and AWS. GCP was popular just for the reason of Google BigQuery, but nothing else. But yeah, Azure and AWS are like very good choices. Cool. But nowadays I can see like people are like using a lot of GCP as well. But if you will compare GCP with other two giants, the data solutions that they provide, bro, you cannot even compare. So Azure and AWS are like very popular. Now the thing is, now you are a data engineer, right? Now you need to pick the entire, or basically you need to understand all of the solutions that you have within each cloud provider, because it makes sense, because every organization is using cloud. So let's say your organization uses Azure. Let's take an example. Cool. So now you know that for data ingestion, you need to first of all understand like how to ingest the data, how to integrate the data. So you can just use a service called, let's say, Data Factory, which is a very popular service, right? Then if you just want to store that data, so we do not have S3 in Azure, we have Data Lake. Okay, Data Lake Gen 2. Perfect. Then let's say you want to perform transformation. So yes, we have Spark support in that Azure as well. Then let's say you just want to store your data. So we have, let's say, Synapse or nowadays Fabric. And let's say you just want to use Apache Kafka, then you simply go with Event Hub and so many other things. So I want to say that now you need to pick one cloud and you need to understand and learn all of these things related to that cloud. You cannot mix things together. Like you can, no one can stop you. But if you want to become an end-to-end complete data engineer, you first need to master all of the technologies, all of the tools, and you need to first of all complete all of those concepts with related to one cloud only. Oh, because once you master one cloud, then you can easily switch to any other cloud, let's say AWS or GCP. It will be very easy. But you first need to master one stack, because the thing is, some technologies are like very popular in Azure tech stack, which are not very popular in AWS, and vice versa. For example, Apache Kafka. Apache Kafka is very popular with AWS, and we have managed Kafka in AWS, but we do not have managed Kafka. We have Event Hub. Like obviously conceptually both are same, but we do not have that thing, right? But when you know either Event Hub or managed Kafka, you can easily switch between two. Oh, same with Synapse. Here we have Synapse Analytics, okay, and there we have, let's say, your Redshift. Then you can easily switch between two. Here we have, let's say, Spark, and there also we have like managed Spark, so you can easily switch. And here, yes, we have Databricks, and we have Databricks with AWS as well. So that is the same. But yes, there are so many things that you need to understand, because it is not like directly same, because how Databricks talks to your cloud actually makes a difference. And in Azure, it talks through connectors and Unity catalog, and then you just create external locations, everything. So you need to now understand the complete stack. Okay, and now let me just show you one complete end-to-end Azure data engineering stack, like Azure Data Engineer architecture, if you are able to understand it. So let me bring it here. Perfect. So data engineering using Azure. Oh, promoting my videos. Wow, nice. So yeah, I just created one complete bootcamp, I think months back, but yeah. So let's go to any architecture. And I just want to use the official documentation so that we can just see what is there in the Microsoft documentation. I think, let me just bring the Microsoft documentation. Maybe this one. No. Let me just find it for you. So I just found this image from the official documentation. So as you can see that, first of all, we use Azure Data Factory to ingest the data. Then we use Azure Databricks to build bronze, silver, gold layer, as I just mentioned about the medallion architecture. So these are the storage, and then you have Azure SQL Server Modeler, then serve, and then all of the machine learning models and reporting, whatever you want to do. And everything is governed by your Entra. This is again like Microsoft service within Azure network, and with Microsoft Entra we just manage our users, all of the permissions, all of the service principals, like everything, right? And keywords is again for the secrets. So now if you will just look at any data engineering architecture, let's say from any cloud, you will be able to understand what are the things being done. Oh yeah, now you will be able to understand what is being done. Now you do not need to worry about like what is this thing, what is that tool, why we are just using Airflow, and when we should just use Airflow, when we should just use Databricks, and what is Delta Lake. I think now you will be having a very clear picture about everything in the world of data engineering. I think so. So this is all about your data engineering 101. So I hope you learned a lot of things. So yes, hit the like button, drop a lovely comment in the comment section, and see you in the next video. Happy learning.